Hello, welcome to 12.6. This is the whole section on symmetry. Okay, so there are three types of plane symmetry. So we're talking about 2D shapes. There's first a line of symmetry. This would be like the mirror image. A rotational symmetry and a point symmetry. Now, when a figure has a line symmetry, then that means half the figure is the image of the other half. And so sometimes you'll find there's multiple lines, and that will tell us what rotational and point are. So let's go ahead and do some examples. Okay, so here's the official definition of line symmetry. It's when a figure, each half of a figure is the image of the other half under some reflection in a line. So let's talk about these figures specifically. Now, the triangle is an equilateral triangle, and it has a line of symmetry. Now, I could still draw several lines, but really it's just one line that makes it a reflection. Now, if I look at the circle, it has infinitely many diameters. So I could put that line anywhere. And the rectangle, it does reflect about this line, but let's talk about it a different way. So more than one line of symmetry. Now the circle, like I said, has infinitely many lines of symmetry as long as they go through the center O. And the rectangle has a second line of symmetry that makes it a reflection horizontally as well. A figure has rotational symmetry when the image of a figure coincides with the figure after a rotation. So the magnitude of a rotation must be less than 360 degrees, because if it's 360 degrees, it's really just one line of symmetry. So here's an example of rotational symmetry. If you open your textbook to 526 and traced the figure in 12.19, that's what this three-petaled flower kind of is. You trace it. If you were to keep the center fixed and rotate it until it looked exactly like this figure again, you would have to rotate it 120 degrees. So this figure has a rotational symmetry of 120 degrees. But let's go ahead and draw a line of symmetry first. It also has another line of symmetry and a third line of symmetry. So if I take 360 and I divide that by the three lines of symmetry, I end up with 120 degrees. So I rotated that exactly 120 degrees enough times so that I'm back to the original position. This figure is also in 12.19, and it does not have a rotation of 120 degrees. It has two exact lines of symmetry, one left to right and one up and down. So if I rotate this figure 90 degrees, it won't be exactly the same, but if I rotated another 90, or a total of 180, this would be called point symmetry. Okay, this is an example of point symmetry because it reflects about 180 degrees. So the definition of point symmetry is a rotational symmetry of 180 degrees. So let's talk about what kind of symmetry this hexagon has. It's a regular hexagon. And if I go through the center, it has many lines of symmetry. This would be the bisector of every side. I could also do angle bisectors. So this has many lines. This has 6 lines of symmetry. So this hexagon has point symmetry, line symmetry, and rotational symmetry. It has all three. Okay, so I've given you some practice problems. A couple of them are multiple choice, so but there can be more than one answer. So be careful, take your time, and make sure to check your answers, and I will see you in class.